All right, there. Welcome back. Now, what I want to look at today again is to look at shock and overload and short circuit protection. Now, let me run that again. Shock, overload, and short circuit protection. Okay, that's what I want to look at today now. Um, Again, this will be on video and it will be labeled as such. Okay, so please feel free to view it, but you cannot access the videos yet, as there you need a lot of information prior to getting to this stage. Okay, so what I've done is to look at it from stage by stage, allowing you to acquire knowledge and some understanding. Now, obviously, you will need to do some of the maths as well. Okay, so practice, practice, practice. Okay, let me just get organized and then let me get to work. 1 second. Now, again, you're not going to see what I'm looking at, okay? But you'll need to look at it from the video stage, okay? Okay, my position. Okay, let me just get up, set up. Okay. WordPress. Yes. You bring an angle in. Okay. Yes. Okay. Okay. Okay, right. What I want to look at sitting gills again, continuing with sitting gills. Okay. And we're going to be looking at short circuit, overload, and shock protection. Again, short circuit, overload, and shock protection. Okay. And the aim and objective of this session is to understand what shock protection means, describe the means of protection against electric shock, describe the differences between short circuits and overloads. Okay. Okay, revision, you've done that already, so this is for you to read. Make sure you've covered the work, otherwise there's no point getting to this stage. Okay. Now, protection against electric shock. When we are, make sure we can get this on screen before without, what is it? When we are dealing with earthing and bonding, we need to look at basic protection. This gives protection against electric shock by eliminating the possibility of coming into contact with a live part, usually by the use of insulation or barriers or enclosures. Fall protection. Fall protection is provided to remove the risk of electric shock as quickly as possible when a fall occurs. Okay, so let me just see if I can. Okay, so I just it's okay. I've got something here looking at something else. Okay, okay, okay. Okay, I've got something here. Right now, it's okay. I've removed something. Bear with me for a second. Yes. Okay, what to do? So, okay, something is just blocking my view for a moment for the little text. Okay. Okay. Fall protection is provided to remove the risk of electric shock as quickly as possible when a fall occurs. Some of the following will provide both basic and fall protection. Some of the following will provide both basic and fall protection. Automatic disconnection of supply, double or reinforced insulation, electrical separation, extra low voltage provided by SELV or PELV, protective measures for application only where the installation is controlled or under the supervision of skilled or instructed persons. Okay. And this medical fabric, I've had to come just to get my framework in. Okay. So, okay, sometimes it doesn't always go as you like because certain text, even though you run it, doesn't always come out as it should. But it's good now. It's good. Automatic disconnection of supply. The protective measures of automatic disconnection of supply (ADS) combines the requirement of basic protection using insulation and/or barriers or enclosures with the requirements of for fall protection using protective earthing, protective equipotential bonding, and automatic disconnection in case of a fault. ADS is the protective measure used in 99% of all installations that you will work on. The automatic disconnection of supply. Okay. You set up an equipotential zone by connecting together all the exposed conductive parts and extraneous conductive parts to a common point. Now, again, you're familiar with the equipotential bonding because you know that takes in your gas pipes, your water pipes, etc. Okay, so we're looking here now at automatic disconnection of supply. We are trying to understand, sorry, we're trying to, on the fault conditions, make sure that enough fault current flows to cause the protective device to operate within the relevant time, usually of 0.4 seconds or 1 second. That would read like 40 milliseconds to me. Would that be 40 milliseconds? Okay, I could be wrong. Just thought. During the earth fault, all metalwork will rise to the same potential. This means that if anyone touches any two pieces of bonded metalwork, the difference in potential will be kept to less than 50 volts, preferably 0 volts. Okay, and let me just go in so you can see what they're doing here. Okay, so I'm showing you the earth fault path that occurs if need be. Okay, but of course we're trying to ensure that there are no faults that will occur or any potential that will cause a hazard to anyone within the domestic environment or elsewhere for that matter as well. Okay. Here we're just having a fault here. Voltages between exposed conductive parts and extraneous conductive parts, and between any adjacent extraneous conductive parts to be very small. Okay, so by earthing it, you made the potential to reduce that fault, causing damage or shock to anybody else. But what should happen is that the protective device should have operated within 30 to 40 milliseconds, basically, or 0.4. Sorry, 30 to 40 milliamps is okay. I was thinking 0.4 seconds or 1 second. Okay, basically. Okay. Now again, you need to look at the video for automatic disconnection of supply in regards to this. Okay, it tells you a lot here. Now I'm looking here at basic protection. There are two ways in which basic protection can be achieved: insulation of live parts, barriers, or enclosures. Okay, and you can see a fuse box here is covered over and sealed away. Okay, basically. Now double or reinforced insulation. Double or reinforced insulation is a protective measure in which basic protection is provided by basic insulation and fault protection is provided by supplementary insulation, or basic and fault protections are provided by reinforced insulation between live parts and accessible parts. This protective measure is more likely to be used in parts of an installation rather than the whole. Okay, and you have class 2 symbol, okay, for double insulation. It's basically, well, some people might call it a square, some might call it a cube. You arrive at your own decision. Electrical separation is a protective measure in which basic protection is provided by basic installation of live parts or by barriers or enclosures. Fault protection is provided by simple separation of the separated circuit from other circuits and from Earth. Okay. And here we're looking at the supply for transformer in a bathroom. Okay, double wound transformer. Yeah. Extra low voltage protection. Okay, protection by extra low voltage is a protection measure which consists of either of two different extra low voltage systems, SELV or PELV. Okay. 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 I'm sorry. Anybody else? Sorry, my apologies. It's okay. I need to mail send it. Goodness me, once it knocks it out of frame, or system, it can play havoc. Try and get it back into place again. Okay. Okay, protective measures where the installation is controlled. There are three protective measures that fall under this heading. These measures are non-conducting location, protection by earth-free local equipotential bonding, electrical separation for the supply to more than one item of current using equipment. Okay. All of them dangerous to use other than protective measures and mean a competent person must be in control of such systems. Now, here we have protective devices, circuit breaker, fuses, etc. Protective device is the name given to a wide variety of electrical components, from the common fuse to more complex devices such as circuit breakers. Protective devices are installed to protect the cables from short circuits and overload. Remember, your protective device is there to protect the cables. They're not there to protect the individual. Okay, basically. They are not there to stop people getting an electric shock, nor are they there in case anything goes wrong by making the fuse blow. It is important to know the difference between an overload and a short circuit. Short circuit and overload. BS 7671 states that a short circuit is an overcurrent resulting from a fault of negligible impedance between live conductors having a difference in potential under normal operating conditions. Now again, you need to confirm that BS 7671 is still there and still maintain this uh, point of reference. Okay. Now again, you need to look at the current regulations, whether that be the 17th edition, 18th edition, or the 19th edition of the IE regs. BS 761, BS 7671 calls an overload an overcurrent in a circuit which is electrically sound. The circuit may be sound, however, the load or appliance connected to the circuit may demand more current than has been allowed for in the circuit, thereby causing an overload in regards to the current being drawn through the cable, thereby causing the cable to get warmed up, thereby causing the insulation on the cable to be damaged. Thereby, you will then have a breakdown of insulation and you will therefore have a breakdown of the circuit, because assuming that that conductor and insulation begins to break down and it's run across any kind of copper pipe, it will certainly go down to earth and blow or should trip your protective device. All right, protective devices. A protective device therefore protects the circuit from short circuits. Sorry. A protective device therefore protects the circuit from short circuits by operating. This can be done by blowing or tripping. Protective devices usually operate on one of two principles: heat. Either the protective device gets hot and melts, or it bends a bimetallic contact in opening a switch. Magnetic. With an increase in current, there is an increase in the magnetic field. This increase causes a metal rod to move and thus operate a switch, which strips it from the circuit and therefore protecting your circuit from overheating. Reliable fuses, semi-enclosed. These are going out of date now actually on the BS3036 because I just had mine replaced the other day. The BS3036 type of protective device are very simple yet very effective. They are called reliable or semi-enclosed fuses. Okay, it is very simple but very effective. Okay, 5 amps, 30 amps basically. Okay. When a current flows in a circuit, heat is given off. If the current is greater than the heat rating, the fuse will be unable to dissipate the heat and the fused wire will melt. This type of fuse is only good for current up to 100 amps and voltages up to 250 volts. Now, advantages and disadvantages of BS3036. No moving parts, cheap, melted element is easy to see, low replacement cost. Basically, very little cost actually. You can read the disadvantages for yourselves. And here we have various types of fuses, okay? But what I was hoping to have here would be a number of circuit breakers as well. Maybe that's coming up. But so one of the things that I noticed about the circuit breakers is that you put in a circuit breaker board, a 12-way distribution circuit board, right? Which your RCDs and your circuit breakers. You may have two RCDs in your board plus the main switch. You may have 5 or 6 circuits being controlled by the RCD. Okay. It's okay. I've just lost my point here. So it's okay. It'll come back to me. Cartridge fuse BS1361 and BS1362. These are your cartridge fuses here, okay? This is a very common fuse found in plug tops and small control circuits. Okay. High rupture HRC fuses, high rupture capacity fuses. This type of fuse is quite expensive and is commonly used in industry. These are what 100 amps basically HRC high rupture capacity fuses. Okay. Advantages: discrimination between short duration overload and high fault counts. Simple to observe when the fuse has blown. Accurate current rating, consistent in operation. Every fuse in the box is the same. Not liable to deterioration. Okay. Okay, and here's all circuit breakers to BS EN 60898. Now check that the standard is still relevant in regards to the IE regulations. Okay, all I'm going to do here is to take in close to have a closer look at that. Okay, and also here as well, take in have a closer look at that info. Okay. Okay. And I don't really need to read anything here because this you can read for yourselves. Okay, I've panned back largely so I can get it fully. Okay. Okay. A circuit breaker has two means of tripping, magnetic and thermal. Okay, one is heat, one would be an increase in the magnetic field causing the circuit to trip out. Okay. Okay. Is that me? Almost. Almost. And here is the advantages and disadvantages of your circuit breakers. Now you can see here that the variation in temperature can affect the circuit breaker. Okay. That brings me back to what I was talking about, the circuit breaker not operating before the RCD, basically. So some of these can become stuck or prefixed in their position. So I suppose from my perspective, I'm just looking at it from the perspective that if the circuit breaker fails to operate, then the RCD comes into play. Okay, thank you. I hope you found this useful and have a good day. Bye bye. Bye bye.